That's fine. It's not like you're gonna remember the answers. Okay. So sometimes I'll write limits like this because when I ask you for a limit, I'm looking for what the y value is approaching. So it says x approaches whatever f of x, which remember f of x is essentially the same thing as y, right? Approaches whatever. So I'm going to give you the x value, and then I'm asking you for the y value that is being approached. Not necessarily like the y value, but the y value that's being approached. So we got a couple examples here. Today's a little more straightforward. Tomorrow we're going to do some trickier examples. So as x approaches 2, so you kind of think about, I don't know what Miss Mahaney used to like describe it. Bugs shaking hands. So they might not shake hands.
No, so they're like trying to shake hands, and if there's a hole, they can still shake hands. But if
there's like this.
If there's like a divide, they can't reach.
Okay. All right. So we got a bug coming from over here. We got a bug coming from over here. They would meet. They'd be able to shake hands. The limit there would be 2. I'm sorry, 1, because that's the y value. All right. F of 2. This is like just, I'm telling you the x value is 2. What is the actual y value at that point? And sometimes that's the same as the limit, and sometimes it's not. So in this case, it is. If I said when x is 2, what's y, you would tell me 1. So the roads, I usually think about like roads. Do the roads connect or not? So that's how, I mean, I can like try to switch, but I'm going to fall back on the roads thing because I've been doing it for 20 years. So if the bugs can shake hands, is separate from whether there's a point or not, or point there or not. So like in apparently this is number 2. The limit here, so these bugs are coming along, and they're trying to shake hands, and they're close, they can reach across, and that's what she would say? Okay. So I would say like, do the roads meet? And the roads do meet, they do connect, and if they do connect, then you look at the y value, where they look like they would connect, even though they don't. They look like they would connect at a y value of 1, right? But what is the value, the actual value of that function when x is 2? It's not there. There's nothing. So it does not exist. And that's okay. The value of the function and the limit can often be 2 different things. And then this third one, so the limit is still going to be 1 because those roads are still coming together at 1. Y value of 1. But the value of the function is 3. That's like where that closed dot is. And again, that's fine. The limit and the y value don't have to be the same thing. If they are the same thing, if the limit and the y value are the same, does anybody remember what that is called? A removable discontinuity looks like this, where I could just like move the dot and I could get rid of that discontinuity. I'm saying, what is it called if it's like this, where the limit and the y value are the same? Starts with a C. Continuous. So if they meet, everything's joined together, there's a bridge there, there's a road there, the bugs run into each other, whatever you want to say, that's called continuous. I appreciate the participation. Alright, I'll do a couple of these. Try a couple of them. So limit as x goes to 1 of f of x. So x equals 1 is here. I kind of jump a little bit to the side of 1. Like I'll go, that's not describing it. I'm going to go toward 1 from the right. I'm going to go toward 1 from the left. Are those roads going to connect? They are. And what is the y value that it looks like they should connect at? Is negative 1. What is f of negative 1? Oh, that's probably one of the other questions. No, it's not. Okay, what's f of 1? Does not exist or undefined because if I said when x is 1, what's y, there's just nothing. This one is does not exist. Let's go to number 3 and 4. So we're looking at x equals 2. So when x approaches 2, so X is like sneaking up on 2 from this side, sneaking up on 2 from this side. They're both sneaking up to the same Y value. They're both sneaking up to 2. That's this 2. And then f of 2 is, okay, when x equals 2, where is the actual closed dot? And that's at 3. Question on those? Give me like, thumbs up, I totally get this. It's easy, thumbs down, I don't have a freaking clue what you're talking about. Sideways. Okay, do the other, like, 2, 6, 7, and 8. I'm just thinking like it's weird that there were 6 guys in this class and I didn't know. You all set.
We don't
No,
know
I'm
each
sorry,
other.
but, like,
We
all
don't
of
know
us.
each other. We all know each other just fine.
Yeah,
We
yeah.
all have.
We all know each other, but not me. That's a weird.
Oh, it's because they were in this class of all.
You guys all had crap for integrated?
Yeah.
Or you didn't take it? Did you all take it?
Yeah.
Okay.
We've always visited each other. Class plus we're in the same spot. That's why we all time.
Alright, I'm gonna put up these 4 answers, but I'm going to get one incorrect. Wait till I'm done, don't like shout it out so everyone can kind of look at it. But I want you to tell me which one I got wrong. So, wait a second. Seriously, you have one job. Carter, why is 2 wrong and what should it be? It's a hole and not a dot. So let's be very careful about how we're saying things. Like the word "it" in here is actually really bad. Because I don't know if it's the x value or the y value at this point. And later we get into you're going to look at an original graph, a derivative graph, and a second derivative graph, like all together. You're going to be like, it has a value of, and I'm like, which one? So let's just try to think, like, don't say it, try to say like the actual terms. I'm not trying to pick any, I'm just trying to use this as an example to talk about it going forward. But f of -3 is right, it should be 0 because that's where the closed dot is, and the limit will be there because that's where the roads connect. Good there? Alright. I don't think 9 and 10 are going to be too much trouble for you then, but let's look at them. So 9 would say, so I'm saying as x approaches 7. Tell me. This is saying as x approaches 7. What? F of x approaches 10. Does it mean it will be 10? No, it just means it approaches it. Or you could say as x approaches 7. So you could say y or f of x approaches 10. You don't have to say both, but just one of them. And then do those 2 true or false real quick. saying f of 1. This is saying the y value is equal to the limit in all cases. True or false? It's false. So an example would be like something like this. Where that's the limit, and that's the y value. If these are equal, what's it called? Continuous. Everything's like nice and smooth. And it's just continuous. True or false here? It's the y value is not equal to the limit in all cases. That's false because there are definitely times when like it looks like that, and it's just nice and smooth, and everything fills in, and they are equal. Questions on the first 10 there? All right, so do the 1.2 homework right now. Let's see, we might be able to like check this and move on.